Hello my friends, and welcome back to Sky Creative Channel. Today, we're taking you on an incredible journey through 6 remarkable production processes that showcase how traditional craftsmanship beautifully merges with cutting-edge technology. So let's get started. Welcome to the heart of England's pottery country. Here at Wade Ceramics in Stoke-on-Trent, we're witnessing a manufacturing process that's been refined over more than 200 years. What makes this facility truly special isn't just its history. It's how they've seamlessly integrated modern technology with time-honored techniques. Our journey begins with the clay preparation system. Watch as raw materials, including the famous local Staffordshire clay, are fed into these massive pug mills. These aren't your grandmother's pottery wheels. These computer-controlled mixing machines can process up to 2 tons of clay per hour, ensuring perfect consistency through precise moisture control and vacuum degassing. The clay emerges with exactly 22% moisture content, a precision that would have been impossible to achieve consistently just decades ago. Now here's where things get really interesting. Wade uses a combination of traditional slip casting and modern pressure forming. Those gleaming stainless steel molds you see? They're precision machined to tolerances of just 0.1 millimeters. The hydraulic ram presses operate at 150 tons of pressure, shaping each piece in under 30 seconds. But notice the skilled operators. They're not just button pushers. Each one has years of experience, reading the clay, adjusting pressure and timing based on humidity, temperature, and the subtle characteristics of each batch. The drying chambers are engineering marvels in themselves. These controlled atmosphere ovens maintain exactly 45 degrees Celsius with 65% humidity for the first 12 hours, then gradually reduce moisture levels. Infrared sensors monitor each piece, preventing the cracking that would ruin hours of work. It's this marriage of technology and craftsmanship that allows Wade to maintain their reputation for zero-defect premium ceramics. Finally, we reach the glazing robots. Yes, robots! But watch closely as human artisans guide each piece through the process. The spray booths use electrostatic application, ensuring even coating while reducing waste by 40%. The kilns themselves are computer-controlled to within 2 degrees Celsius accuracy, with firing cycles that can last up to 36 hours. The result? Ceramics with the durability to last generations and the beauty that's made English pottery world-renowned. From the rolling hills of the Basque Country, we enter the workshop of Arieta and Arisabalaga, where gunsmithing remains as much art as it is engineering. This isn't mass production. Each shotgun here takes over 200 hours to complete, and watching these craftsmen work is like witnessing a masterclass in precision manufacturing. Let's start with the barrels, the heart of any fine shotgun. See that massive horizontal boring machine? It's a 1960s Pratt & Whitney that's been meticulously maintained and upgraded with modern digital readouts. The boring head rotates at exactly 180 RPM while advancing at just 2 millimeters per minute through the steel barrel blank. This creates an absolutely straight, perfectly smooth bore with surface roughness measured in micrometers. The steel itself? Premium Damascus steel, heated in gas forges to precisely 1,200 degrees Celsius. Now watch master craftsman Juan Carlos select each walnut blank. He's not just looking at grain patterns. He's reading the wood's density, moisture content, and stress patterns built up over decades of growth. That pneumatic duplicating lathe follows a master template. But see how Juan constantly adjusts pressure and cutting speed? He's compensating for the wood's natural variations, something no computer can replicate. The action assembly is where 300 years of gunsmithing tradition meets modern metallurgy. Each part is hand-fitted using precision files and stones. That may look old-fashioned, but those digital calipers ensure tolerances of 0.02 millimeters, tighter than most automotive components. The springs are individually tested for exact tension, and every moving part is polished to mirror finish using diamond compounds. The final assembly process takes 3 full days. watch as they hand engrave the serial numbers using traditional gravers, then proof test each gun with loads 30% higher than standard ammunition. The laser bore sighting system ensures perfect alignment, while hand checkering provides grip texture that will last for generations. Each gun leaves here not just as a tool, but as a precision instrument worthy of the world's finest hunting estates. Here in the dramatic landscape of Hardanger, Norway, we're witnessing something truly special, the recreation of maritime rope-making techniques used for over 400 years. The historic ship Gurin requires authentic 4-strand hemp rope, and master rope-maker Erik Hogan is one of the last craftsmen who knows these ancient secrets. Our process begins with raw hemp fibers that have been retted, that's soaked in seawater for exactly 28 days to break down the plant's natural pectins. Erik examines each handful with the eye of a master, feeling for the perfect balance of strength and flexibility. These fibers are then hackled through progressively finer steel combs. You can see how each pass removes shorter fibers and aligns the longer ones. This isn't just preparation, it's the foundation of rope strength. Now comes the spinning, and that's not just any spinning wheel. This is a maritime rope spinner, custom built in 1847, and still functioning perfectly. The spinning ratio is precisely 8:1, meaning 8 turns of the wheel create 1 twist in the yarn. Erik controls the tension entirely by hand pressure. Too loose and the rope will stretch under load, too tight and it becomes brittle. Watch his fingers work. Decades of experience allow him to maintain perfect consistency even as the hemp varies in thickness and texture. Here's where traditional meets necessity. The spun hemp yarn must be treated with pine tar to resist saltwater rot. This heated tar bath maintains exactly 80 degrees Celsius, hot enough to penetrate the fibers completely, but not so hot as to damage them. The yarn passes through at precisely 2 meters per minute, ensuring complete saturation. Modern temperature controls guarantee consistency that sailing masters of old could only dream of. The actual rope laying is performed on this walking spinning frame, essentially a 30-meter-long rope machine that Erik operates entirely by hand. 4 strands of tarred hemp are twisted together in the opposite direction from their individual spin, creating incredible strength. The magic happens in the tension control. Erik adjusts each strand individually, ensuring the rope remains perfectly round and balanced. One strand too tight, and the rope will develop a permanent curve under load. Every rope length is stress-tested to 150% of its working load using these traditional wooden blocks and a hydraulic test rig. The rope must show no permanent elongation and no strand separation. Finally, each rope is hand-spliced with traditional techniques. No modern hardware touches these historic lines. The result is rope strong enough for ocean voyages and authentic enough for maritime museums worldwide. Welcome to Vicard Tunnelleries in France's Burgundy region, where the ancient craft of barrel making combines French oak mastery with precision engineering. These aren't just containers, they're precision instruments that will influence the flavor of some of the world's finest wines for decades to come. Our journey begins in the oak forests, but the real magic happens here in the seasoning yards. These French oak staves have been air drying for exactly 3 years, not a day less. Master Cooper Michel Vicard explains that kiln drying simply cannot replicate what natural weathering achieves. Rain leaches out harsh tannins, while seasonal temperature cycles break down cellular structures that would otherwise create bitter flavors. Each stack is rotated quarterly using this overhead crane system, ensuring even exposure to the elements. Watch this computer-controlled stave planer. It's removing exactly 2 millimeters from each surface while following the natural curve of the oak grain. The cutting heads spin at 6,000 RPM with carbide blades sharp enough to produce a surface finish that requires no sanding. But notice how Michel hand-selects each stave. He's reading the grain pattern, checking for knots or defects that the machine cannot detect. 40 years of experience goes into every selection. The assembly process is pure craftsmanship, enhanced by modern tools. These hydraulic hoops apply exactly 2,000 pounds of radial pressure while Michel positions each stave. The ancient Cooper's adze has been supplemented by pneumatic versions, but the skill remains entirely human. Watch how he shapes each head joint. The angle must be perfect to within 1 degree, or the finished barrel will leak. No glue, no fasteners, just precision-cut wood held by compression and centuries-old techniques. Here's where science meets art. The toasting process uses computer-controlled gas burners that maintain precisely 180 degrees Celsius on the interior surface. But Michel controls the duration entirely by sensory evaluation, listening to the wood crackle, watching for exactly the right color change, even smelling the oak as its flavor compounds develop. Light toast for 12 minutes creates floral notes, medium toast for 18 minutes adds spice characteristics, and heavy toast for 25 minutes produces rich vanilla flavors. Every barrel undergoes pressure testing at 15 psi, twice the pressure it will ever experience in wine service. Laser measurement ensures the head diameter is accurate to within 1 millimeter, while traditional water testing confirms absolute leak-proof integrity. The final sanding uses 320 grit paper to create the smooth finish that will make cleaning easy while preserving the precise toast level that will flavor wine for years to come. Welcome to Koma Furniture Workshop, where Japanese precision meets modern woodworking technology to create their signature kokoda chair in precious ebony wood. This isn't furniture. This is functional sculpture that represents the pinnacle of contemporary woodworking artistry. Master craftsman Takeshi Koma begins with ebony planks that have been air drying for over 5 years. African ebony is among the hardest woods on earth, nearly twice as dense as oak, and working it requires both exceptional skill and specialized equipment. Watch as he inspects each board under these full-spectrum LED lights, reading the grain structure like a book. He's looking for consistent density, checking for hidden stress fractures that could appear months after completion, and selecting boards whose grain patterns will create visual harmony in the finished chair. The initial breakdown uses this 5-axis CNC router equipped with diamond-tipped cutters specifically designed for exotic hardwoods. The cutting program took over 80 hours to develop, accounting for ebony's tendency to splinter and its dulling effect on cutting edges. The machine operates at half normal speed, just 2,000 RPM, while flood cooling prevents the extreme heat buildup that would scorch this precious wood. Each rough component emerges within 0.5 millimeters of final dimensions. Now we transition to pure handwork. That antique-looking plane? It's actually a modern Holte smoothing plane with a blade of laminated steel harder than surgical instruments. Takeshi's technique removes shavings just 0.02 millimeters thick, so fine they're nearly transparent. The secret is maintaining the blade at exactly 45 degrees to the grain direction while applying uniform pressure across the 2-inch cutting edge. The joinery showcases why Koma Furniture commands premium prices. These mortise and tenon joints are cut entirely by hand using Japanese chisels that Takeshi sharpens daily to razor keenness. Each joint must fit with what woodworkers call piston fit, tight enough to require firm pressure for assembly, but never so tight as to risk splitting the ebony. The tolerance? Just 0.1 millimeters across the entire joint surface. Creating the chair's signature curved backrest requires steam bending, especially challenging with ebony's notorious brittleness. The steam box maintains exactly 100 degrees Celsius saturated steam for 45 minutes per inch of wood thickness. But watch Takeshi's timing. Ebony has perhaps a 30-second window between perfectly pliable and starting to fracture. The bending form is heated to 80 degrees Celsius to prevent thermal shock, and the entire process must be completed in under 2 minutes. The surface preparation takes nearly as long as all previous steps combined. Starting with 180 grit sandpaper and progressing through 220, 320, 600, and finally 1200 grit, Takeshi removes every trace of machine marks while preserving the wood's natural texture. Between each grit, he raises the grain with distilled water, then sands again, a process that ensures the final finish will be flawless. Final assembly uses hide glue heated to exactly 60 degrees Celsius, the traditional adhesive that allows future repairs if ever needed. The finish is 12 coats of hand-rubbed tung oil, each coat cured for 48 hours and then polished with 4,000 grit micro mesh. The final result? A piece of furniture that will develop a richer patina over decades while maintaining its structural integrity for generations. Each Gakoda chair represents over 120 hours of handwork and embodies the philosophy that true luxury lies not in ostentation but in perfection of execution. Our final stop brings us to SNF Filters, where precision engineering meets high-volume production to create the pneumatic filter components that keep industrial equipment running smoothly worldwide. This is modern manufacturing at its most efficient, combining automation with quality control that ensures every component meets aerospace-grade standards. The process begins with this fully automated material handling system. Raw aluminum stock is laser scanned for dimensional accuracy, then fed into CNC machining centers via robotic loading systems. These aren't just any machines. They're 5-axis machining centers capable of holding tolerances of 0.005 millimeters while processing 200 components per hour. The secret is in the work holding fixtures, precision ground to ensure every part is positioned identically for machining. Watch this synchronized machining operation. While one component receives final drilling and tapping operations, the next is being rough-turned, and a third is undergoing quality inspection. The cutting tools are monitored continuously by vibration sensors, and automatic tool changers replace worn cutters before they can produce out-of-specification parts. Each component undergoes 23 separate machining operations in under 3 minutes. Every single component passes through this coordinate measuring machine that checks 47 different dimensions in 12 seconds. Components outside specification are automatically rejected and recycled. The filter media itself is ultrasonically welded using precisely controlled heat and pressure cycles that create joints stronger than the base material. Finally, each filter undergoes automated flow testing at pressures up to 150 psi to ensure consistent performance in demanding industrial applications. The result? Filter components that maintain tight tolerances in environments from Arctic oil fields to desert construction sites, proving that modern manufacturing can deliver both precision and reliability at industrial scale.